Greetings and welcome, friends. Today we are talking about section 3.2 in our Big Ideas Geometry textbook. We're talking about parallel lines that are cut by a transversal line. All right, here we go. This is going to be awesome. These are all the theorems you've been waiting for. Actually, I'm kind of surprised. Corresponding angles theorem, back in my day, this was called corresponding angles postulate, and we assumed it was true. But that's interesting. It looks like we might have a proof on page 30 or exercise 36. There's ways that I guess it could be verified. So let's see. Corresponding angles theorem, which I'll probably be calling postulate because I also abbreviated as CAP in my reasons for my proofs. It says this: if two parallel lines are cut by a transversal, then their pairs of corresponding angles are congruent. So let's see. It says, in the diagram at the left, which diagram do you ask? This diagram that I have not yet copied and pasted onto the screen. Let's see, is there even room on the left? Not really. But there we go. In this diagram right here, look how adorable that diagram is. Angles 2, all right, right there, and angle 6 are corresponding angles, and according to this, they are congruent to one another, as well as, for instance, angles 3 and angles 7, or angles 5 and angle 1. All of the corresponding angles belong to us. So, Theorem 3.2, AIAT, which is actually AIAT, maybe, is how you pronounce that. That's how I abbreviate it. AIAT. AIAT, you guys got this? Two parallel lines cut by a transversal. The pairs of alternate interior angles are congruent. Let's look at our little diagram again. Okay, alternate interior. This guy and this guy. It's saying angle 3 is congruent to 6. Do you believe it? Well, believe it, friend, but not yet until we do the proof, maybe. And then also angle 5 would be congruent to angle 4 by the alternate interior angles theorem. All right, good stuff, good stuff. I don't know, maybe you saw that coming. Maybe this is all a surprise to you, but it's wonderful. Let's see, alternate exterior angles theorem. Alternate exterior angles are going to be congruent. Wow, isn't this great? So let's see, angle 1, what's the alternate exterior angle to 1? 8, right? Alternate because they're on opposite sides of the transversal, and they're on the exterior because the interior is here. All right, right? So those will be congruent to one another. And then lastly, we've got consecutive interior angles theorem. Good stuff. And these ones, oh, don't let it fool you. These ones do not have congruence. They have supplementarianness. Supplementalness? Supplementacity. The supplementacity of these angles are the most. They're the most supplemental they can be. They definitely add to 180. Like the most that they ever could. Or the least that they ever could. Like they're exactly supplementary to one another for consecutive interior angles theorem. Now, if I was to have a theorem regarding consecutive exterior angles, notice that I would actually have come to the same conclusion, that consecutive exterior angles also are supplementary. My proof, because 5 and 8 are vertical angles, 3 and 2 are vertical angles, and then like, I don't know, substitution or something. Proven. That's how quick I prove these things. Well, you at least get the idea. So let's do some exemples of this. It's gonna be great. It's gonna be great. It's gonna be good. You guys can follow along on your little piece of paper there. Identifying angles. The measures of 3 of the numbered angles are 120 degrees. Identify said angles and explain your reasoning. Okay, so here we go. This is 120 degrees. I'm claiming that angle 4 is one of those. So the measure of angle 4 is equal to 120 degrees. Why do you think that's true? What types of angles are those? Those are none of the ones that we've already listed in this lesson. Vertical angles, that's right. VAT, vertical angles theorem, friends. Okay, let's see, another angle that's 120 degrees, I'm going to say is angle 5. Measure of angle 5 is 120 degrees. because it is what kind of angle with this original 120? Yeah, corresponding angles. I guess we're calling it a theorem now, so now it's just cat? Really? Cat? Well, I guess if I at least flag my video with cat on YouTube, maybe I'll get more hits. So here's like a cat geometry, parallel lines cut by a transversal video. There you go. Let's see, what's the other angle that's going to measure to 120 degrees? Anyone see it? Angle 8. And let's see, what's one explanation for it? It's a vertical angle of 5, perfectly good explanation. How does it relate to the 120? Alternate exterior angles theorem. I like it. So therefore those are congruent. It's also a corresponding angle to angle 4. So there we go. I mean, right? You just kind of know the name, you know the property, and then you apply it. And it's great stuff. I love this stuff, guys. Aren't you pumped? Are you pumped about parallel lines? Yeah. The audience heard the cheering. They heard it. Yeah. Man, settle down, class. I know you're really excited. I'm going as fast as I can. Please. There's so much geometry I want to teach you. I know. Please. You will all be taught the geometry. Oh, my goodness. Let's see. Here we go. Find the value of angle x. The value of x. Okay. Now, angle 115 here is going to also be congruent to which angle? Angle 4. Why? Yeah, vertical angles theorem. And then what types of angles are 4 and this angle? Consecutive interior. And what can you tell me about the measures of consecutive interior angles? They are supplementary. So we are going to say that x plus 5 plus 115 is equal to 180. Right? And in this case, they didn't ask us to justify all of our reasons, so we will not. I will give you no explanation. Let's see. So, and then I can solve. I'd combine like terms there. We'll subtract 120 from both sides using the classic subtraction property of equality, friends. I love it when Algebra 1 comes back. So looks like x is 60. Bam, done. You love it yet? You guys love it, don't you? You're loving it. Okay, here we go. Guys, these problems are el más fácil del mundo, aren't they? They're just. So here we go. Example 3. You guys already got this on your paper. All right, find the value of x. How does angle 136 relate to angle 1? Supplementary. Why are they supplementary? What's the name of this one? They are two angles. A word for that is pair, and they form a line. They are a linear pair. The linear pair postulate, LPP, yeah, you know me. Linear pairs are supplementary. Right? No? What the heck was that? I don't know. It just comes out of me. So, angle 1 is supplementary to angle 136. Angle 1 is congruent to angle whatever this guy is. How do I know those are congruent? Alternate exterior angles theorem. So, if these two are congruent, then their measures are equal by def of Kong, and therefore 7x plus 9 plus 136 is going to equal 180. Looks like I did some substitution there, friends. I don't know. Maybe there was a quicker way. Were you? So you would have. Oh, you did the supplemental part first. Yeah, you could have. You could have. So let's see. Let's solve this. So plus 9 and plus 136. That sounds like math. 7x plus 145. I'm guessing. Oh, I love it when they happen to conveniently give us nice angles. Subtract 145 from both sides. Looks like 35. Oh, guys, look at this. They set us up for success. Divide by 7. Both sides. Scroll bar. And I've got x is equal to 5. X equals 5. And actually, I labeled the previous example with degrees, but x is actually not going to be measured in degrees. The entire angle is in degrees, but x is not going to be. That's fine. Don't worry about it. I wouldn't really mark it wrong or nothing, but yeah, there we go. So I'm kind of using these properties and solving things, and eventually we're even going to do proofs. What are you guys love the proofs? You're like, I don't believe anything unless it's proven to me by theorems, postulates, definitions, and properties. Yeah. All right, so here, check this out, friends. It says this, prove the alternate interior angles theorem. That means that since I'm trying to prove it, I cannot assume that it is already true. Okay? All right, here we go. I'm gonna 2-column it. You guys like the 2-column proof. Excuse you. All right, here we go. I'm gonna set up some double columns. That's close enough for me. Let's see, 2-column proof. What? Look at those columns. Beautiful columns. Over here we'll have our statement. And over here we'll have reason. That's why practice makes perfect, friends. Actually, as Daniel Tiger says, keep trying, you'll get better. And then that's usually when my son yells at me. He says, stop, stop. He doesn't like it when I sing songs to him from TV shows that he's watched. There we go. Okay, there you go. So guys, statement. Let's say P is parallel to Q. Reason? Given. Okay, all right, there. That's easy. I'm going to say angle 1 is congruent to angle 3. Why do you think those are congruent? Corresponding angles theorem, CAT. All right, I'm going to say that angle 3 is congruent. You guys see where I'm going here? To angle 2. Why are these two angles congruent? I thought someone said it. Vertical angles theorem. And let's see, does someone see what I can do here using the substitution property of equality? Or actually, no, I lied. Subs prop congruence or trans prop congruence, whatever. Actually, I think technically there is no substitution property of congruence, but we'll just call it transitive. Trans prop congruence. So what's transitive property tell me? Yeah, because angle 1 was congruent to angle 3, angle 3 was congruent to angle 2, therefore I can just cut out the middleman and just say angle 1 is congruent to angle 2. And look we've kept this problem generic enough that we have actually proven it for all cases like it. So yeah, good stuff. Good stuff. Let's see, last example. If you believe in your dreams enough, this last example is gonna work for you. Look at rainbow. Oh, wow. Guys, believe in yourselves. Yeah, you get a grayscale rainbow on your paper. Yeah, there you go. I like it. So it says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. I can taste it. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1? And how do you know? I'm going to say angle 2 is congruent to angle 1. How do I know that? Alternate interior angles theorem. Right? They're alternate interior angles. These rays of light are presumed parallel. I know theoretically they aren't. And let's see, if the angles are congruent, then their measures are equal by def of cong, right? Congruence to equality or equality to congruence. It's def of congruent. And therefore, I can say that measure of angle 1 is going to equal 40 degrees. Why? Substitution with this given statement right there. Subs prop equality. Bam, there you go. And now you can go out and enjoy the rainbow and not be as perplexed as you once were. Thanks for watching, Internet friends. Bye-bye.